The topic of this video is showing how to wire and control a stepper motor. Unlike a normal DC motor, stepper motor does not run continuously, but rather in discrete steps. That makes it easy to control precisely how much we want it to turn. Let's first go through the wiring of a stepper motor. Stepper motors come in different shapes and sizes, but they will almost probably have these 4 wires. They represent the 2 coils that provide magnetic field for the rotor's permanent magnets. It is important to distinguish between the 2 coils and wire them correctly, otherwise the motor won't turn. You can probably find wiring information from the website you got the motor from, or you can figure out the coil pairs with a multimeter. A stepper motor will always require a driver, and they also come in different shapes and sizes. The one I'm using is A4988, and the wiring details might differ between drivers, but the wiring information will be found from the datasheet of the driver. In my case, we need to connect the 4 wires from the motor to the driver, and also positive and a negative wire to provide external power to the motor. We should also add this 100 microfarad capacitor in between those. We need 2 wires to connect to the pins of the microcontroller, one of them controlling the steps the motor takes, and the other controlling the direction. One side note is that depending on the motor and the driver, it might be possible to use microstepping, thus enabling even smaller resolution, but we won't go into that. Lastly, we need to connect the microcontroller's voltage output and ground to provide small current to the driver logic. Before going into how to control the motor with code, couple words about the principle. Like said, a stepper motor takes discrete steps, and by controlling the amount of steps, we control how much the motor rotates. By controlling the delay between steps, we control how fast it takes consecutive steps, meaning how fast it rotates. Now the actual coding. Because I'm using an Arduino copy as a microcontroller, I will be using the Arduino IDE, but the same principles probably apply to other types of controllers as well. First, we want to declare the pins, one for taking the steps and one for the direction. Then we can build a function for taking steps. It takes the amount of steps, the delay in microseconds, and the direction as parameters. Note that the direction is either 1 or 0. We first tell the motor which direction it is supposed to spin. Next we build a for loop which goes through the amount of steps that we want the motor to take. We set the step pin high, wait the time defined by the delay, then we set the step pin low and wait the delay again, and voila, the motor has taken 1 step. So now this same procedure is repeated in the for loop as many times as defined in the first parameter. Now we just need to call the function in the main loop, and we can add a bit of delay between each call to distinguish them from each other. Now we just need to upload the code to the Arduino and plug in the power for the motor, and we see the motor rotating. We programmed the motor to take 1000 steps, meaning 5 full rotations, since this motor takes 200 steps per rotation. Just for fun, I added a potentiometer to control the delay between each step. You can see how the speed of the motor changes when I turn the potentiometer. The delay goes from 1000 microseconds to 500. Here is the code for changing the speed with potentiometer, and this is the important line. Here in the for loop, in between each step, the Arduino measures the potentiometer's position and maps the analog value into a value between 1000 and 500, and that value is now used as the delay.